Today we are looking at some more laws of logs. Okay, so we have three different properties here that we're going to talk about. These a product rule, a quotient rule, and a power rule. Okay, so looking at these, the quick shortcut version is basically if you're taking a log and the argument of your log is something that you can break down into two factors, then you can split it into two separate logs that have been added together, not multiplied, but added. Okay, so as an example of this, if you have something like log base b of 10, since 10 is the same as 2 times 5, you can rewrite this as the log base b of 2 plus the log base b of 5. Okay, the quotient rule is that when you have something where your argument can be divided, you can break it up into two logs that have been subtracted. So as an example, log base b of 10, right? Since 10 is, say, 20 divided by 2, I could rewrite this as a log base b of 20 minus log base b of 2, because 20 divided by 2 gets you 10. And then our last one is log base b. So in this case, what it's saying is that, see how there's this exponent on the x? You can actually take that exponent and drop it down into the front. So I think about it like taking this guy and dropping him down into the front there. Okay, so like if you had log base b of 5 squared, that's the same as 2 times log base b of 5. Okay, so that's what these different properties are. Okay, so we're going to look at the proof of where these things come from to show you that this is something that actually works. Okay, so this is something that you can actually do. It'll actually work. And we're going to walk through the proof. So these proofs, right? You may remember proofs from geometry and you're like, oh no, proofs, those are horrible. They're not as bad as you think necessarily. Okay, I find algebraic proofs, for me personally, I like them a lot more than I like geometric proofs. Okay, so we're going to walk through this one step at a time. All right, follow along and try to just figure this out. Okay, so let's start with this first one. So we're going to start with our product rule. So the product rule says that a log base b of x times y is equal to the log base b of x plus the log base b of y. I had to pause there for a second to go investigate a mysterious kitten noise in the other room. Ruby is being trouble today. She's just getting into everything, knocking things over. It's a good time. Okay, so here's what we're going to do first of all. So what we're going to do is I'm going to take this part, okay, and we're going to rewrite this expression a whole bunch of different ways, okay, so that we're eventually going to come to this answer, okay? So this is our goal that we're trying to figure out. So I'm going to start with a log base b of x times y, okay? And the first thing that I'm going to do is I'm going to say, all right, these two numbers x and y, okay, I am going to rewrite those as some number b raised to some power. Okay, there is some number out there. I don't know what number it is, but somewhere out there is a number. You can always do this, right? Where b to some number m equals this x value. Okay, so whatever the number is, you can somehow rewrite it so it's a power of something else. Okay, so that's what we're going to do here. I'm going to take this number x and rewrite it as b to the m. So like as a example, right, if I had something like, say it was 8 and we had log base 5 of 8, right? And I want to rewrite this number 8 as some power of 5. There is some number that you can raise 5 to. I don't know what it is, but there is some number that exists so that it would equal 8. Okay, that's possible. There's some number. It's more than 1 and less than 2, but it's some number. It'll work. So there's something there. So we don't know exactly what it is, but there's some number that will work. Okay, and then similarly with y, I'm going to do the same thing. There is some number, I'll call it n, that when I raise b to that power, it's going to equal whatever number y is. Okay, that's just a thing that exists. Okay, so we're going to make those definitions, and using that, I am going to rewrite this as log base b of b to the m times b to the n. I'm substituting this guy in for x and that guy in for y. Okay, great. Well, now I've got these two things multiplied together with the same base. So there's a rule that says I can rewrite this as log base b of b to the m plus n, right? If they have the same base number, you can add your exponents. So I can rewrite that as m plus n. Lovely. Okay, well, one of the properties that we looked at last time said that if you have the same base number here as you do here, these pretty much cancel each other out. And then you can Tetris this down and say that is the same as m plus n. Okay, so we're getting there. We're actually almost done. So we've now rewritten this as a much simpler n plus n. But the problem is that we want it in terms of x and y. I don't know what m and n even are, right? They're just some number that makes these things work. So what I'm going to do is I'm going to go back over here and we're going to figure out an expression for m. So using my log rule, I'm going to rewrite this as a logarithm, right? So remember, little number becomes the big number, so that's my base. The number in the middle wanted to be left alone, so that's the x. And the number on the outside wanted a friend, so that's the m. So I can rewrite m as log base b of x. And then similarly with this guy, right? The little number became a big number. Number in the middle wanted to be left alone. Number on the outside wanted a friend. Log base b of y is equal to n. So using that information, I can go back over here and say, okay, well, this is equal to, we said m was the log base b of x, and n was the log base b of y. So we've proved what we were trying to prove, that when it's two things that are multiplied together, you can break it into two different logs that have been added together. That's the rule that we were looking for. Awesome. Okay, so that is our first proof. All right, now our second one, we're going to look at the quotient rule. Okay, so the thing that we're going to try to prove is we're going to try to show that a log base b of x divided by y is equal to log base b of x minus log base b of y. This is our goal. This is what we're trying to prove. And this proof is actually going to be pretty similar to the last one. So let's kind of walk our way through it, okay? So the first thing that I'm going to do is I'm going to take a look at this, and I'm going to do the same thing that we did before. I'm going to start with this guy, and I'm going to just change this guy until I get to this. So that's how you're supposed to do a proof. You're doing an algebraic proof. You start on one side of the equation, and that's the only thing you change until you get to the other side. You can't like change both things at the same time. That's cheating. So this guy right here, we're rewriting this. So the first thing that I'm going to do is I'm going to do that same thing we did above, where I'm going to redefine x as some power of b, right? There's some number that when I take b and I raise it to that number, it's the same number as x. Okay, so I'm going to rewrite this as log base b of b to the m. That's how we defined x up here. And I'm going to do the same thing with y. I'm going to redefine that as b to the n. Okay, well then this expression, when you divide two things with the same base, there's an exponent property that says you subtract the exponents, right? So this is the same as log base b of b to the m minus n. Okay, these have the same base values, so we know those are going to cancel out. That equals just m minus n. And then similar to how we did before, right, we defined up here, we rewrote it and said m is the same thing as log base b of x, and n is the same thing as log base b of y. Okay, and that is the end of our proof. We showed that we can start with this side, and just changing this one expression, we can eventually get to this thing. So that's the end of our proof. Okay, so now let's prove the last one. So the last one is our power rule, this thing that says you can take this exponent and just sort of drop it down the front. Okay, so let's look at this guy. So I'm just going to copy that rule down here. So the log base b of x to the n, we want to show that this is the same thing as n times log base b of x. That's what our goal is. So we're going to start on this side and keep rewriting things until we get to this. Okay, great. So, oh, sorry, I'm trying to be consistent in my color and I picked up the wrong marker. Oops, log base b of x to the n, that's where we're starting. Okay, so it will not surprise you that we're going to use the same thing we did before. So just like before, we said x is the same as b to the m. That's what I'm going to rewrite here. So I'm going to rewrite this as log base b, and I'm rewriting x as b to the m. And then that n was already there, right? Okay, well, then there's a rule with exponents. Exponent rule says I can rewrite this and multiply m times n together. So this is the same as log base b of b to the mn power. Okay, here's that same property. Those guys cancel each other out, and that leaves me with just m times n. Okay, but m, remember, is this guy up here. Okay, so I can make that substitution and say this is the same as log base b of x times n. Now, I'm not going to swap this n out, right? Because remember, we never actually use this definition. I never use this definition anywhere in this problem. So that's why I'm not actually subbing that out. And you know what actually I think I'll do is I'll say, let's pretend this was a different letter. That was like a P, right? That's more of what we did, is we multiplied it that way. So then what we're showing is now I could rewrite this if I wanted to as P times log base b of x. Okay, so I just changed that to a different letter, just so that it's not the same as the letter we've been using. Okay, and then that's the end of my proof. So I showed the thing that I was trying to show. Okay, so that's what an algebraic proof is like. They're kind of fun. They're sort of like puzzles. These ones are pretty simple algebraic proofs, and you're like, Miss King, there was nothing simple about that. But yeah, they are. They're actually pretty simple algebraic proofs. But yeah, so that's some growing pains for you. If you're interested in pursuing higher mathematics, those are kind of the sorts of things that you do. Okay, so now that we've proved all these things are true, let's go ahead and use them. So let's look at these guys. So here we're going to evaluate this expression. I'm adding two logs together, and my rule says if I'm adding these two logs together, that's the same as if they were multiplied inside of one log. Okay, so this is the same as log base 2 of 8 times 4 is 32. So it's the same as log base 2 of 32. Okay, and then there's a couple of different ways that you could simplify this. So you could think about it as looking at this number and saying, okay, well, that is the same as 2 to the 5th, right? So then you've got log base 2 of 2 to the 5th, and that cancels and gives you 5 as your answer, right? Or you could think about it as converting 2 to what power equals 32? 2 to the 5th power equals 32. So you could do that either way. All right, this one's a subtracting of two logs. Notice the base numbers are the same. They have to be the same, okay? So when I subtract these, this is the same as log base 3 of 3 divided by 27, right? And 3 divided by 27, simplified as a fraction, that would be 1 over 9. Okay, so then to simplify that, two ways you could do it. 3 to what power equals 1/9? Or you could rewrite this guy as a power of 3. So two ways you could do it is you could use that whole 3 to what power equals 1/9 and then think, okay, well, I would have to square it to get to the 9 and then flip it. So -2 would be my answer, right? Or you can look at this and say, okay, I need to rewrite 3 as 1 over 9. So same sort of thought process where you're saying, okay, I need this to be a 3. So 3 to what power is the same as 1/9? Well, a negative to flip it and a 2 to make it a 9. And then those would cancel and you get -2. So two different ways that you can figure that one out. All right, this guy, we're adding two logs together so I can multiply those. 40 times 25 is 1,000, which I know you just knew off the top of your head. Okay, and then remember, there's no base number written here, which means by default it's a 10. Okay, so by default, your base number is a 10. So I could think of this as 10 to what power equals 1,000, or you could think of this as log base 10 of 10 to the third. But either way, you're going to get 3 as your answer. Okay, this guy right here, we're adding. So this is the same as log base 6 of 36, right? And since 36 is 6 squared, that's just 2. And again, you could simplify it the other way by converting if you wanted to. All right, so that's a way that we can use these rules to evaluate. Now we're going to use them to expand some things. Okay, so let's take a look at these. So this first guy here, we're going to start by expanding this. Well, this is a product of 2 things. So I can rewrite this as log of 5 plus log of a. And there we go, that's it. All right, this guy, so we can break this into log of 6 plus log of b. But because 6 is a product of 2 factors, we can actually break this down more. Okay, so we can break this down into log of 2 plus log of 3 plus log of b. Okay, you can skip this middle step if you want to, but you do need to expand it the whole way. Okay, so anything that you have that's not a prime factor, you need to break it down into the product of primes. All right, this next guy, so this one I can break into log of 5 plus log of a squared plus log of b, because those are all multiplied together. But then I can also use the rule that says I can pop this down in the front, right? And then this becomes log of 5 plus 2 log of a plus log of b. Right? And if you think about it for a second, that should make sense too, right? Because a squared is a times a. So just like how we took the 6 and we broke it down into 2 and 3, you could take a squared and break it down into a and a, right? So it would be log base 5 of, log of 5 plus log of a plus another log of a, aka 2 logs of a. All right, this guy here, this is a division problem, so I can rewrite this as log base 5 of a minus log base 5 of b. Okay, make sure that you're copying over those base numbers. They should stay the same. This guy, I can break this into log of 3a minus log of b. But then 3 times a, that can be broken down, right? So this is the same as log of 3 plus log of a minus log of b. Okay, and again with this one, I'm okay with you skipping that middle step if you want to jump right to there. All right, this guy, I can rewrite this as log of a minus log of bc. All right, and then here's just the thing that you need to watch out for, right? We're subtracting this log. So when you break this, it's going to be log of a minus log of b plus log of c. So this negative ends up getting distributed to both of these. Okay, so it's going to be minus log of b and then minus log of c. The way that I think about it, anything that's in the numerator is going to be positive. Anything that's in the denominator is going to be negative. Okay, so similarly, when I look at this guy, right, I'm going to break this apart and it's going to be, I'm going to do this all in one step, right? I'm going to have the log of 2 plus the log of x. Those are both positive because they're in the numerator. And then it's going to be minus log of 3 and minus log of y because those both end up in the denominator. Okay, and the logic y is the same as what we did here, right? When I subtract log of 3y, you end up distributing the negative. Okay, so this guy, really long. So here's what we're going to do. So the log of 6, break that into its primes, so 2 and 3. So I'm going to have log of 2 plus log of 3 plus log of x plus log of y, all positive because they're all in the numerator. And then the 5z squared, that's all in the denominator. So it's going to be minus log of 5, and then minus log of z squared. But we actually have one more thing we can do. We can take this exponent and drop it down into the front. So rewriting all this, be log of 2 plus log of 3 plus log of x plus log of y minus log of 5 minus 2 log of z. This is why we call it expanding, right? Look at how long that is compared to that. So that's why this would be the simplified version. This is the expanded version. Okay, this guy, he's going to be much shorter. So this one, when it's a square root, what you're going to want to do is recognize that this is the same as x to the 1/2 power, right? Square roots and power of 1/2, those are the same thing. And then I can take this guy and drop him down. So it's 1/2 times the log of x. All right, our last two down here. So this guy, this I can rewrite as the same as log of 5x squared y to the 1/3 power. Okay, and then this will drop down, right? So it's the same as 1/3 times this log of 5x squared y. And then this guy I can break up, right? So this will be log of 5 plus log of x squared plus log of y. Still got my 1/3 chilling out. I can drop this guy down to the front. So that'll be 1/3 log of 5 plus 2 log of x plus log of y. Okay, and then the last thing I have to do is I have to distribute, right? This 1/3, all of this stuff was in the square root. So the 1/3 has to get applied to all of it. So it's going to be 1/3 log of 5 plus 1/3 times 2 is 2/3 log of x plus 1/3 log of y. Okay, and that is the whole thing broken down. Okay, I did a lot of steps there that I wouldn't necessarily have done if I were doing this problem out just on my own, right? I probably would have taken it and jumped from here to maybe here, and then probably honestly from there right to the answer, right? I would have brought the 1/3 down and the 2 down as I was breaking it up. Okay, last one. So this one, the difference here is that now this 1/2 power only applies to the z. So this is the same as log base 2 of 4x cubed y and then z to the 1/2. So the 1/2 only goes with the z because that's the only thing that was in the square root. All right, breaking this up. Now, you could look at this and say, okay, well, log base 4, or log base 2 of 4, right? 4, I can break that into 2 times 2. So you get a couple options here, right? We can take this and say, okay, well, that's log base 2 of 2 plus log base 2 of 2, right? And then plus, I'm going to do this at the same time. I'm going to bring this 3 down as I split off a log. So it's going to be 3 times the log of x. Okay, see how I skipped that step? I would have had log of x cubed, and then I brought the 3 down in the front. Okay, and then plus log of y, and I'm going to do the trick again here. I'm going to shortcut this, right? It would be plus log of z to the 1/2, and then I'd bring the 1/2 down like I did there. So it's going to be plus 1/2 log of z. Okay, so let's go back to this 4 thing. So we took the 4, we split it into 2 and 2. Here's the thing you need to watch out for. Yeah, these cancel out, but they cancel out to 1, not 0. Okay, so log base 2 of 2, that cancels to 1, right? And log base 2 of 2 cancels to 1, right? And then plus blah, 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 all that other stuff, right? So this is going to simplify to 2 plus 3 log of x plus log of y plus 1/2 log of z. Okay, that's one way you could have done it. The other thing that you could have done is when you were way back up here at log base 2 of 4, you could also recognize that 4 is 2 squared, and that would just be 2 then. Okay, so either way works. what's actually happening here, right, is we're taking this guy, we're dropping it down in the front. So this is 2 times log base 2 of 2, and log base 2 of 2 is equal to 1. So this is 2 times 1. That's where we get that answer from. Okay, so that's what's actually happening with that property. So you can kind of see where it comes from. All right, so those are our lovely laws of logs and how you would use them to evaluate or expand. So the last thing is going the other way, condensing. So these ones are really long and we are going to simplify them. So we're going to try to do this in as few steps as possible. So what we're doing with this guy, start by dealing with any numbers that need to come back up. Okay, so any coefficients, you want to bring those up first. So I can make this log base 3 of x minus log base 3 of y squared. And then since this is a subtraction, I can rewrite it as a division problem. And there we go. Okay, so this guy, same thing. So I'm going to bring this 1/2 up. I'm going to bring the 2 up. So this is going to be log of a to the 1/2 plus log of b squared minus log of c. Okay, but a to the 1/2, that's the same as the square root of a. So when I put all this together, I'm going to write it as log of the square root of a times b squared, and then divided by, because we're subtracting, c. So the two things that are positive go in the top, and the thing that's negative goes in the bottom. All right, and then typically with something like this, we would actually rewrite it as b squared times the square root of a. So the square root's in the back. That's conventionally just kind of how we clean those up. All right, so then this guy, I'm going to bring the 3 up, I'm going to bring the 2 up, and I'm going to go ahead and do this all in one step. So this is going to be the log of positive, so the a is going to go in the top, negative, and I'm bringing the 3 up, so b cubed is in the bottom, negative, and I'm bringing the 2 up, so c squared is in the bottom. Okay, and then last one. So again, I'm going to try to do this all in one step. So this is going to come up, this is going to come up, that's going to come up. So it's going to be log, and since I've got some positive and negatives, I know it's going to be a fraction. This is positive, so that goes in the top. Negative, so it goes in the bottom. Positive, so it goes in the top. Negative, so it goes in the bottom. Positive, so it goes in the top. And there we go. That's our fully condensed expression. Okay, so the more that you get used to these properties, the easier it is to do these faster and with fewer steps. Okay, so you'll kind of adjust to it as you go along.